Hello students, this is Neha Mathur and today in this video we are going to discuss about the detailed classification of signals. Fine. So before starting the topic, consider to subscribe my channel and click on bell icon to get updated for the upcoming videos. Then please click on like button. Fine. So our today's topic is classification of signals. Students, this is the second video from a series of signals and system subject. In the last video, I told you about what is signal actually and the main category of the signals, in which I told you that we have two major category of the signals, which was continuous signal and digital signal. Now today I will tell you that whenever we are going to discuss about the representation of the signal, we have two domains. We can represent our signal in the form of time domain as well as frequency domain. Just an example, if I'm talking about some basic examples of the signals, I can say that human speech is itself an example of basic signal. Similarly, we have multiple examples from electrical signals like voltage, current, power. All these are signals. So we can represent them in the time domain as well as frequency domain. Whenever we are going to broadcast a signal in the form of communication, in the area of the communication, we need to convert that signal in the frequency domain representation definitely. But today I will tell you that if we have time domain representation of that signal, then we can represent that signal, and how we can represent that signal and what will be the classification for that signals. Fine. So under this we have two major categories of signal. The first one is continuous time domain, continuous time signal, and the second is discrete time signal. I am again repeating that at the basic I am again repeating that at the basic level we have two type of signal, digital and analog. It may be a time domain. We can represent that digital and analog signal in the time domain as well as frequency domain. But whenever we are going to categorize them on the basis of only time domain representation, in that situation again we have a two type of classification: continuous time domain signal and discrete time signal. You can write it like only continuous time signal and discrete time signal. No need to represent domain term because it is just a representation. Now the thing is, what is continuous time and what is discrete time? See, always remember that for the continuous time signal, I will always take T as a major parameter, while for the discrete time signal we will take N for the representation of a particular term time. Continuous time signal is always represented with respect to time, while discrete time signal is always represented with respect to sample n. This is also for time, but for the discrete time signals. Fine. So we have two type of representation. We have two type of signals, continuous time signal and discrete time signal. Now what about their definition? See, it again, this is just like an analog signal. In analog signal, I told you that if a signal is an analog signal, which means that we will have infinite value of that particular signal. Similarly, we can define this term that continuous time signal is a signal in which we have a infinite values or all the values for amplitude as well as for phase with respect to time. So if you have infinite value, or I can say that if you have a values at any instant of time, that the signal comes under a category of time signal. Why I am saying this continuous time signal? Because this is represented with respect to time only. Now the thing is, what about discrete time signal? Again, discrete time signal simply means we will have some limited value of that signal with respect to time. This is the reason it is said to be discrete time signal. Meanwhile, it is again same as digital signals, because in digital signals, again I told you in the last video that in the digital signals or in a discrete signal we will have some limited samples. So we can define that same definition, that we can apply that same definition for this here also, that here we will have limited values. But again, these values will be represented with respect to time. Fine. So now I am going to conclude a proper classification, again repeating that we have two type of signal, analog signal and digital signal, but whenever we are talking about the representation of that signal, in that situation we can represent any signal in two domains. It may be a time domain or it may be a frequency domain. Frequency domain representation we will discuss later on, because before that you must have knowledge about some basics of that subject. Firstly, we are discussing about time domain representation, and whenever we are talking about time domain representation, we will have two category: continuous time signal and discrete time signal. In continuous time signal, time is represented by small t, where here we will use small n. Here we will have infinite value, or I can say I have multiple values. Here I have limited values to define that particular signal. This is a basic classification of the signal. Now, if a signal which may be a continuous time signal or which may be a discrete time signal, it has several more categories. Like this particular signal which may be a continuous or discrete, it may be a deterministic signal or random signal. The second category is it may be a energy signal or power signal. Third category is periodic or aperiodic signal. I should write and term here instead of or, because these are the categories. The fourth category is casual and non-casual signal. And the last category is even and odd signal. So, we have 5 major categories of a signal which may be from continuous time signal and from discrete time signal. I am again repeating their names. The first category is discrete and random signal. The second category is energy and power signal. Third one is periodic and aperiodic signal, casual and non-casual signal, and the last one is even and odd signal. So, how you can use these terms with a single signal? See, if I am representing one signal with the help of x of t, which is a representation for a continuous time signal. If the signal belongs from discrete time signal, then it will be like this, x of n. So, if I have a signal, suppose I have a human speech signal, my voice, then that particular signal, which is a continuous time signal, it may be a deterministic, it may be a energy, it may be a periodic or aperiodic, it may be a casual or non-casual, it may be a even or odd signal. So, a single signal may opt any 2, 3, 4 or 5 or all the type of category belongs from a signal. So, in a simple manner, I can say that a single signal may be a deterministic or random, may be energy or power, may be periodic or aperiodic, may be casual or non-casual, or even and odd signal. So, this is all about the classification, brief classification of the signals. In the next video, I will discuss about each and every classification of signal in detail. Fine. I hope you are following my content. If you are liking this, please consider to subscribe my channel and click on bell icon to get updated for the upcoming videos. Fine. Okay, thank you.